Hey guys, Jacob here with Digital Airless. For this week's First Things First, I wanted to get a little bit of the content that I didn't include in the actual blog post. A lot of that came out of interviews with this guy right here, CEO Jeff Alholm, and thought we'd get him here to talk about some of the things that I left out of the blog post. So, given that these are all about fly-by-wire in the aviation industry, Jeff, how do you where does that experience come from?
Oh yeah, that was the question, wasn't it?
It was, yeah.
Yeah, it's a long story, but let's just say I've made the misfortune of investing in two airplane companies.
Okay.
No,
Okay.
it was okay. Yeah, I learned a lot. It was fun. It was, I learned a lot about carbon fibers. I paid a lot of aeronautical engineering firms to design planes that were in the sports and high performance categories. It was fun.
Good.
You're
Great.
going to be in Kansas, man.
I tell you what, aviation capital of the world, not too far south of here. So,
So the rumor goes.
yeah, so it goes. Cool. Well, about the fly-by-wire stuff, I remember there being sort of a historical context that we walked through last time.
Yeah. So, again, when I studied electrical engineering, a lot of control systems were based around avionics. Back when dinosaurs ruled the earth, as I jokingly say. And those control systems were mostly about aviation, so that was kind of one of my loves. So I think as we were talking about it, we were talking about kind of this trajectory of fly-by-wire,
Mm-hmm.
and also autonomy, because at some point they something morphs between the two, and there's probably clear definitions that are unique between the two. We sometimes intersperse, we conflate those two.
Blur together a little.
So let me continue the conflating. Is
Conflate on.
conflate on is. So of course, I learned to fly on a 172, which is a Cessna product, and
Mm-hmm.
it's just a simple airplane. It's very stable. So as you fly and you take your hands off the control, it will nose up or nose down to achieve stable flight if all things are working. And
Yeah.
when you push the control, there's a cable back, and there's little aerodynamic things inside, outside the wings and on the control surfaces to kind of balance everything out. So you have a very, very stable design, and that's why they make 172s now, seemingly 400 years later after
Right.
they started. Well, could be 400, but you get the point. So it's intrinsically stable. And then
And mechanically so, right? I mean, it's
mechanically so. So
part of the mechanical design that makes it.
there's no electronics when you push that control forward.
Yep.
You're all, stick and rudders are all, and pedals are all connected to
Sure.
cables. And military planes don't do that anymore, except for a notable example. We won't get into that. But but that's the stability. Now, fighter planes, modern fighter planes, can't be stable. Now, by the way, early fighter planes weren't as stable as trainers. That's why we had training planes and fighter planes. So fighters are naturally unstable because you need them to be twitchy to roll and pitch and do things you need to do to survive a dogfight.
Some of the agility comes from the instability
It does.
of those
It
things.
absolutely does. And so then what happened is, in the case of, and I'm just going to pick on the F-16, which is an old design by now, is that the F-16 flies by wire, meaning that the control surfaces, there's no cable there, as in most modern planes. And you can do some hydraulic assist, like some Boeing aircraft, even large ones we fly on now, have hydraulic assist. But the point is on an F-16, everything's by wire. You push that, it's a control, and there's a computer there doing commands to the different control surfaces. But on an F-16, actually the computer in the middle is making some decisions. And it's saying, this pilot wants to turn so fast it's going to black them out. I'm not going to let them do that. I'm going to soften that turn so you don't black out. And that is, I don't think that's autonomy in any way, but it's getting close in the sense of the computer's intervening
Sure.
and not letting you do something. And then a cousin of the F-16 is the F-18, and it's the Navy fighter. It's dual engine, and there's a funny thing, if you've ever seen a video in an F-18 taking off, is they make the pilots hold their hands in the air before they push the catapult launch. And the catapult officer is instructed not to push catapult launch unless he can see the pilot's hands in the air. And the hands in the air, there's actually handles they usually hold. And of course, being very, A-type personality fighter pilots, they want their controls in their hands. But it is not letting them do it. It is taking over and autonomously taking off that plane. It might be at every given. Autonomy is a funny thing. There's definitions of level 0, you would argue, all the way to level 5.
Right.
And 5 is it acts like a human. It can make common sense decisions on the road or whatever the process is. If a exit is closed, it knows to go to the next exit and back up. Nothing in the world is level 5. There's an argument whether level 4 is out there, and on a perfect day in Phoenix, Waymo arguably drives in level 4, but even then they have to have a safety driver in most cases. Most, Deutsche Bank just recently published a report, said there's no real autonomous cars on the road today that are above level 2 plus.
Okay.
So that gives you an idea where we're at. So at some level in the F-18, it's level 1, but it is for that takeoff procedure, right?
Sure.
So that's an F-18. An F-35 is a modern jet. It's different forms, but let's just pick on the vertical landing one, is that the F-35B is replacing the Harrier. And the Harrier has the highest accident rate of any airplane in the military inventory. At least that's my understanding. And it's just very hard to land because the control surfaces are all really manual. There's some, there's wires and things, some fly-by-wire in the B version. But the point is, the human is the control system. On the F-35, there is definitely some autonomy going on because it is it is in the middle of that landing process. And as pilots who are interviewed say, it's the easiest thing in the world to fly. So we've gone from the most dangerous jet,
right,
to from just a fatality standpoint, to hopefully one of the safest in the hardest of all landing sequences, other than maybe landing on a carrier, and we'll get to that, is it's doing that automatically. So is it fly-by-wire? Is it autonomy? It's kind of heading toward autonomy, right? So there's a landing sequence, and the computer's there, keeping this thing on the head of the needle, right?
Right.
Now there's an MQ-25, I think I have that name right, and the Navy is basically getting out of the tanker business.
Yep.
And so now they're going to a autonomous vehicle. Now there's a pilot somewhere on the carrier or somewhere on the mainland helping fly that thing, but if it loses communication, it will autonomously return, and its landing process on the carrier is highly autonomous.
And this is the mid-air refueling.
Yeah, and it's a huge drone because it's got big tanks in it.
Sure.
And if you look it up, but it is truly autonomous, right? It is doing, there's a pilot there somewhere in a back room, but that drone they assume is going to lose communication. It will return to base or return to the carrier. And then the landing process, because of the timing of the wireless links, they want it to do as much as possible autonomously. So now let's turn the corner to digital airless. We're kind of in all these continuums. What we did from day one, unlike any other drone provider in the world, we've really not only designed our control systems from scratch, but we've done it in what we called folded geometry framework, which in the early version was in 25 dimensional math space.
Right.
And we manage all the noise and vectors and the kinematics of flight in such a way that we can do some forms of autonomy even 2 years ago in our early products. And now the new 130IR does high autonomy at some processes.
Yeah.
And it does it in a way, autonomy has become a very cheap word these days. A lot of people claiming, autonomous can openers and all kinds of things. And in the drone space, it's getting confusing. People put balls on drones and call them, rugged.
Sure.
And all they're doing is they're bouncing. They're using their instability to roll through things or bouncing off of things. We don't do that. So in our basic form, in the initial product, we could feel a wall. We still feel walls.
Yeah.
And we do it because of these incredibly precise mathematical operators. So, for example, we're able to preserve the gravity vector, everyone else based on their math loses it in a mere seconds. We keep it for tens of minutes longer than a battery runs. So it goes for over 30 minutes. And we're able to maintain that gravity vector and maintain our stability. But in that same way, when we feel a ceiling, we feel the Bernoulli effect of the ceiling.
Yeah.
We'll let you push in the ceiling, but it refuses to get stuck. It will back off, right?
Right.
You wrote some of this code, so I know you understand it. And obviously, when we go into a wall, we feel it's a wall and we rotate. But we feel the difference between a wall, and by the way, we refuse to get sucked into the wall. We know.
Right.
Kinematically, we're not going to do that. And we're not unstable as we push into a wall. And the reason that we allow ourselves to touch a wall, and by the way, we have collision avoidance in the new product coming out, meaning that feature is not implemented yet. But if you want to tell it, don't even get close to the wall in the new unit, you can do that. But the point is, we're doing something very, some level autonomous now.
Sure.
Is that we're sensing a wall. We sense a person. A person feels different
right.
than a wall. And
Person
we
yields.
handle that different.
Yep.
Person yields a little. We see wind. So we automatically, without any wind sensors, without GPS, without optical flow in the first product,
Right.
we're able to sense wind, and we calibrate the wind. So in a mine shaft, we feel the wind, and if you take your hands off the control, it knows to stay there.
'Cause it's fighting against some.
It sees the wind, and it does that through this combination of what we call, certainly in our patents and I think in our marketing materials, empathy filtering.
Yep.
So we are empathetic because in this case we were watching the user. So it's a machine learning technique, artificial intelligence, and we're learning all of these things about the environment. But now, with the new 130, we're able to do some other things with empathy filtering or with this, autonomous behaviors. So now you can do things like, let's go into bridges, which is a specialty of ours, is that we can fly in not only under a bridge and launch under a bridge for a bunch of these same technical reasons, but we can fly inside the deck. So you could have two metal plates and be flying in the metal plate and not be bouncing around, but actually flying stably.
Also not get sucked into the bottom.
Not get sucked to the bottom, not any of that. And you have to enter the slot. But the hard part for our clients have been, as you enter that slot, there's kind of, you and I would call them eddy currents, but there's
Right.
swirling winds
Yep.
around this bridge deck as the wind goes through it. And all the smartness in the world, that's very hard to handle those that buffeting. But now we're able to do that because now the drone has a spherical view of the world using its optical vision systems, and it sees the bridge, and it knows as you're approaching that bridge, this pilot is approaching that bridge, I'm going to lock optically onto that bridge, and I'm going to choose to be stable in relationship to that bridge.
Yep.
And then as you fly through that deck, it all but does it automatically in an autonomous way for you.
No pre-scanning, no.
It's scanning all the time. So there's no, in the sense that that's part of the systems.
Right. Right.
And the cool part is because of our folded geometry framework, it all kind of nicely flows in our system. There's no, why the sensor modules themselves are creating some maps, it's not really mapping per se. It's in our multidimensional space, which you know well, you're maintaining these relative frames. There is
Sure.
no absolute frame in our systems. Everything are relative frames. So it gives you a level of autonomy. We often talk about in the new system, there's a new thing, and, it's easily implemented in the 120. It doesn't need the new sensors of the 130. By the way, the 130, if it loses all its external sensors, it still flies as stably as the 120.
Yep.
So stability is not achieved by our sensors. It is enhanced by
That's
our
right.
sensors. So
That's right.
we're stable. And that at some level in this fly-by-wire autonomy continuum, I don't know where that sets, and I'm not going to proffer a theory or an answer other than to say it sits somewhere on there. Obviously, with the new unit, you're seeing some clear absolute autonomy. So now we can fly. I was going to go to the wedge real quick. So the wedge is just the fact that the system now, if you try to do something, you try to do a fast yaw with a change of attitude and control, maximizing the acceleration thrust, the thrust up.
Yep.
Something's got to give in that equation. So now the unit is constantly looking at that and using our folded geometry framework math, we're able to calculate those things, and we will take over from you like the F-16. We won't let you do something
Right. That's right.
So in this case, if you try to do something aggressive, it might yaw when you didn't want it to yaw. Then it will just creep back after you did whatever silly thing you were trying to do.
Right.
And it's just kind of magical. So like the F-16, like the F-18, like the F-35, it's landing that plane
Sure, yeah.
in a very autonomous way. And in this case, it's doing it in this control system. Last but not least is, it's sewer pipes are one of my favorite examples, because now the unit, because it's aware of its environment, it just naturally knows when in a pipe you want to fly in the middle. It will take care of the eddy, swirling airs, currents. And it will, in some ways, not in some ways, very autonomously fly down the center and hold its position. So now there's a position hold in our unit.
Yep.
So without GPS, without traditional optical flow, and by the way, it lights its environment. It does a lot of this stuff in an automatic way.
Yeah.
It just does all these magical, features. And so anyway, in conclusion, I just love talking about airplanes, because in some ways here we've gone from, we were never really at the Cessna 172, right?
Yeah.
But we've gone through F-16s, F-18s, F-35s, and now the MQ-25 kind of stage.
Yeah, great.
So, again, I always love the quote from Alan Kay, is that any technology advanced enough is indistinguishable from magic. Easy for me to say. Is indistinguishable from magic. So, these are the magical things we do.
Yeah.
It's always come join us and participate in making magic with us.
That's right. Come see us at digitalairless.com or click the link below to find out more.